Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving an exponential equation. Happy New Year everyone. I hope you had a wonderful 2023, and I wish this year brings you happiness, laughter, and anything your heart desires for. Alright, let's get started. We have e to the z equals 3 plus 4i. So this is kind of like a complex exponentiation problem. I don't know if we've done anything like this before, but these problems are pretty interesting. And let's get to work. So you might be tempted to do the following. If you were working in the real world, you could probably just ln both sides, right? ln e to the z equals ln 3 plus 4i, and then z, bring it to the front, and ln e is 1, so z equals ln 3 plus 4i. But what is ln 3 plus 4i, right? How do you evaluate it? That's going to be our million-dollar question today. So instead of just keeping it super simple, a very simplistic approach is not going to help us. We're going to work in a different way. So here's what we're going to do. First of all, we need to realize that z is a complex number, just like 3 plus 4i. So the question is pretty interesting. You raise e to a complex power, it's the complex exponentiation, and you get another complex number. And that's what happens all the time. With real numbers, if you use a real exponent, then of course the result is real, right? Most of the time, of course. If you are doing negative 1 to the power 1/2, that's a different story. But most cases, you're going to get a real answer. But this time, it's kind of like the complex to complex. So you can consider this as a function of complex variables, and then it takes as z a number to 3 plus 4i. Anyways, without doing so much complex analysis here, let's keep it sort of simple. Here's what we're going to do. We could probably present two solutions anyways for this, and let's get started. So first of all, since z is a complex number, I want to use a general method that I've been using for so many videos on this channel. If you haven't checked those out, go ahead and check them out. I also have lecture videos that if you're new to complex numbers. Now, let's go ahead and write z as a plus bi. A plus bi is also the name of this channel, right? So that's why hopefully you'll remember that all the time. And now we can go ahead and replace z with that. There's only one z, right? And that doesn't look very helpful, but guess what? This is going to be very, very helpful. So we're going to talk about a couple things. Polar form, you know, Euler's formula, some good stuff, and a little bit of trigonometry. I hope you are fresh on trigonometry. If not, you can go ahead and take a look at some important formulas. Again, in lecture videos, I talked about the polar form and Euler's formula. Now, what do you do in this case? Again, we don't want to ln both sides, at least with the first method. Let's go ahead and do something else. Well, since we have a sum of two things and they are in the exponent, we can go ahead and split it up. A lot of times when people see something like a to the x times a to the y, they're going to write it as a to the x plus y, but not every time people think about something like, okay, we can split it up, right? We can work backwards. We can actually work both ways with an equal sign, but a lot of times the equal sign is interpreted as from left to right, or if you're writing right to left, I guess that's the way to go. Now, here's what we're going to do then. We're going to split up the exponents. So we're going to write this as e to the power a times e to the power bi. You got to remember, a and b are real numbers. So e to the a is a real number. E is Euler's number, which is 2.7-ish, right? I only know one digit. People ask me sometimes, how many digits of pi have you memorized? And I say 2, 3.14. Anyways, I'm not joking. I don't really memorize it. But this is our separation, right? So we kind of split it up, but this is significant because take a look at it. This is real and this is non-real. So that's what happens on the right hand side too. Take a look. This is real, this is non-real. So, but this is a product, that's a sum. That's what's so much fun about complex numbers. We're going to be able to solve it, but we need to turn the right hand side to a product, right? Let's see how we can do it. So obviously e to the bi can be written as x plus yi or c plus di or whatever. I don't want to use a plus bi, obviously. But that's not what we're going to do. So 3 plus 4i, let's think about its polar form. First of all, if I call this w, I'm not going to call it z because the z is already used, right? Z is a plus bi. So let's call it w. And what is the absolute value of w, or r, radius, or modulus? It's going to be the square root of 3 squared plus 4 squared. From Pythagorean theorem, this is going to be 5. And then I go ahead and take out a 5, and then I kind of write my number again. This time, kind of factoring out the 5 and forcing the numbers inside to be fractions so that this is satisfied. By the way, you could write, some people are going to write the I first, doesn't matter, no big deal. Let's go ahead and do it that way, okay? Now notice that these numbers are special because they are the cosine of an angle and sine of the same angle, which is called the argument. So theta is called arg w, which stands for argument, which is the angle. So whenever you graph or plot a complex number, something that looks like this, this is the angle we're talking about. And since the real and imaginary parts are both positive, we're in the first quadrant. Make sense? Now, here's the critical part. What do we know about this right triangle? And if you said tangent, you got it. Great. So tangent theta is going to be 4 over 3, right? Which means theta can be written as tan inverse 4/3. And this actually works nicely because we're in the first quadrant. If you're in a different quadrant like third, where tangent is positive, tan inverse of 4/3 is going to give you the theta, which is the reference angle. You just have to add pi to it. Make sense? I hope it does. Now, where do we go from here? I got the modulus. I need the theta. But I just said cosine theta is this, and so on and so forth. So here's what we're going to do. We can basically write this as follows. 5 times cosine theta plus I sine theta. So don't worry about these values for now, but Euler's formula allows us to write it as 5 times e to the power I theta. And what is theta? Tan inverse of 4/3. Let's go down and plug it in. I times tan inverse of 4/3, which can be evaluated numerically, by the way. And I believe it's about 53 degrees. And I think physics people use the 4/3 and 3/4 a lot. 37 and 53, 90 triangle, something like that. Anyways, those are approximate. So we got this. Now is the time to set it equal to my other number, which is e to the a times e to the bi. So this is our z, remember, right? Actually, z is a plus bi, never mind. I got confused. And this is equal to now 5 times e to the power I times tan inverse 4/3. Now, what do you think about this equality or equation? Well, it just means that the moduli are equal and the imaginary parts are equal. So these are going to be the imaginary pieces. And from here, we can safely say the following. E to the a equals 5, which means a is ln 5. By the way, a is real, so we can just do an real natural log here. And with the second piece, b happens to be this number here. So b is going to be tan inverse of 4/3. Okay? Now, what are we looking for? Z equals a plus bi. Therefore, our number is ln 5 plus I times tan inverse of 4/3. Some people call tan inverse arctangent, but this would basically be the answer. Now, what is the second method for this problem? Let's go ahead and take a quick look because I'll probably leave it unfinished, but you can pretty much do the rest. So e to the z equals 3 plus 4i. You can go ahead and actually write this. You can just ln both sides, and that would give you ln e to the z equals ln 3 plus 4i. And then you're just going to write this as ln 5 times e to the power I times tan inverse 4/3, just like before. And then this is going to be just z. And then you can go ahead and ln this product, which is going to turn into a sum of 2 ln's, and then you're going to get the exact same answer. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Bye-bye, and Happy New Year again.